Today I present you the elemental function feature. It is a program written entirely in Python, and it is able to infer the type of function used to generate the data and fit it, even when there is noise, just like here. It uses the least squares method, and it is able to fit a curve to either one elementary function or a linear combination of two elementary functions. And for a linear combination of two elementary functions, it uses the differential evolution algorithm, a genetic algorithm, to optimize the initial parameters necessary for the least squares method. Currently, the supported functions are polynomials, exponentials, logarithms, trigonometric functions such as sine, cosine, and powers of x. As a result, we have here one function data with noise, two types of noise, both random and given by the measure apparatus, and we can see that here in real life it was a polynomial and it still is a polynomial. It's able to fit it perfectly, and here it is a logarithm in real life, and we can see that the fit of the polynomial and the logarithm are exactly the same. However, thanks to our algorithm, it is able to detect and infer that the function really is a logarithm, and actually really fast, not even a second. For a linear combination of two or more functions, it's actually a little bit harder, it is much slower. However, it can work both without noise and with noise, albeit a little bit slower and not always. It's also able to infer the coefficients, and we see whether the function works or not by the correlation between variables. Here it's without noise and noise, the same function, and so both it's able to detect it's a logarithm trigonometric. And now we show you how the program works. First of all, we need to enter a file name we want to load, which is 1f power. We just know that theoretically this function is a power function, which means it's x to square, x cube, x square root of x, which is one function to fit. We choose the possible functions, polynomial, exponential, you see. Now we'll just use the default settings, and we don't want the full data. And we actually see that it's fitted perfectly with the coefficients, which is 1 times x to the 5th minus 5, and it took 0.1 seconds.